guys, and welcome to our fifth video tutorial of business mathematics. And in this fifth video tutorial we are going to focus on the last question of the revision paper that we had commenced during our first video tutorial. So now we are in the fourth question. A job is advertised at starting salary of $120,000 with an annual increment of 8%. How much will the salary be during the 15th year, and how much will be the total sum earned after the 15 years period? So that is the question, and we are just proceeding straight into the solution. The question is simply testing on a geometrical progression or geometrical series concepts, and let us go look at some of the overview concepts of the geometrical progression. What is geometrical progression? Geometrical progression is a series of numbers or characters in which a term forming the sequence differs from the preceding term by a constant factor called the common ratio. There are a number of components making up a geometrical progression, and the components are as follows. One, we have what we call first term denoted by A. We have the common ratio denoted by R. We have the number of terms denoted by N, and we have sum of the number of terms denoted by S subscript n. There is formula for calculating the nth term of a geometrical progression, and the formula is given as nth equals to A times R raised to power n minus 1, where n is the number of terms, R is the common ratio, and A is the first term. On the other hand, there is another formula for calculating the sum of a series of a given number of terms. The sum of the number of terms of a geometrical progression denoted by S to the subscript of n equals to A into bracket R raised to power n minus 1 bracket all over R minus 1, a case where R is greater than 1. What of a case where R is less than 1? In that case we have S to the subscript of n equals to A into bracket 1 minus R, where R is the rate, R raised to power n, close the bracket, all over the denominator 1 minus R. The first question here, how much will the salary be during the 15th year? That simply, the question requires the 15th term of the geometrical progression. So let's identify some of the elements we have in this question. One, we have A, which is the first term, which is $120,000, the salary. We have N, which is the number of terms, that is 15. Then we have R, which is the common ratio, and the common ratio here is given to be 8% increment, to mean the ratio is 108%. So let us calculate first. Let's go to the next step into calculating the nth term or the 15th term of this GP, and the formula is given as nth term or n subscript of 15 equals to A, which is 120,000, times R, which is 1.08 raised to power n, which is 15 minus 1. So that will be 120,000 times 1.08 raised to power 14. You are going to end up with the answer to be 352,463.23. Let's proceed to the next question. How much will be the total sum earned after the 15 years? This one now requires us to get the sum of the 15 terms, and the formula for getting the sum over GP is given as S to the subscript of n equals to A in bracket R raised to power n minus 1 over R minus 1. So that is going to be, if you substitute through that formula, you are going to end up with an expression like S to the subscript of 15 equals to 120,000 in bracket 1.08 raised to power 15 minus 1 all over 1.08 minus 1. Through, if you simplify that expression, you're going to end up with 120,000 times 2.17216914, or 2.1726 to four significant figures all over 0.08 to the denominator. Then for the simplification, you will end up with 3,258,253.67. And the final step is now to give our answers. The first answer is regarding the amount during the 15th year, and that is what we calculated at first as the 15th term. So therefore the answer to that question is $352,463.23. Now the second answer is regarding the total sum during the 15 years. That is $3,258,253.67. So those are the requirements by question 4. Otherwise, thank you very much guys for now, and this will mark the end of our last question on the paper we commenced in the first video tutorial, and in the subsequent video tutorials we will be proceeding into other issues, other concepts, and other questions or revisions as the time goes by. Thank you for now, thank you very much, and may God grant you a successful moment and future.
Ndiyo siku aloifanya Bwana Mungu wetu. Ndiyo siku aloifanya Bwana Mungu wetu. Tushangilie.